And the final presentation of this track. Why every AI cloud provider needs an in-house LLM team. I'll pass over to Aleksandr Patrushev, the Senior Product Manager in AI and ML at Nebius AI. Thank you very much.
Thank you. And I use this one. OK, yep. Welcome, everyone. Thank you for being here. It's really a pleasure. You already know my name, so and you already see the topic. The reason why I want to talk about this specific topic is that I really believe in it. Before joining the Nebius and become a product manager, I was solution architect for machine learning in AWS for 6 years. And actually, the knowledge which I get there is super essential and helpful for me right now. And I would like to start with a quote of one of the wisest men I have met in my life. If you never heard about him, it's Wagner Vogels, and he is a CTO and vice president of Amazon. So back in 2017, he said that there is no compression algorithm for expertise. You could not learn certain things without going through the curve. But what does it mean? It actually means you cannot find the solution for a challenge until you face it and until you solve it. Why it's important actually for me and for Nebius as a company. Before answering that, let me give you just a brief overview. What is Nebius? You probably never heard about it before. First of all, that's an AI cloud company. So we're building AI cloud. And the main mission is to help AI grow in terms of use cases and in terms of people who could actually build their own things running on AI. The headquarters actually here in Amsterdam. But we have offices around the world. And we have data centers in Finland, in Paris, and we'll be soon going to the US, just first quarter, in a couple of months. What we are inside, so I already mentioned that we are across the world. We have close to 1,000 of the people, and it's actually high-skilled engineers coming from the big tech who decided that they want to build a new cool thing. We are partnered with NVIDIA, and we operate and manage our own data center. But what makes us unique here? Why we're not as many other clouds? So first of all, we own data center. We really build it, we own, we operate it, we know everything inside of it. And we are not buying the hardware on the market. We're actually producing the hardware. We have a team who's designing the chassis, designing the boards, and we're just getting components and then build the servers by ourselves. There is a reason why we're doing that, because first of all, we could guarantee that they're working and operates even with all GPUs running on a maximum power, and we actually could support them. On top of it, we're building our own software, cloud platform, and we have our own language team. But here is the thing, why I started from the quote about the expertise and compression algorithm. As I said, to solve specific challenges, you need to face them. And actually means that if you really want to build an AI cloud platform, you need to have expertise in AI. Otherwise, you have no idea about what challenges exist in AI, how you can build a platform for it. And where we're getting data about the challenges, where we're actually learning. So first of all, as I said, we have our own language team. And they're doing a lot of great stuff. And one of the things was they were training a model, 300 billion model, and they were doing that on more than 1,000 of GPUs, almost for more than a month. And in the end, the best feedback that we get, that they were sleeping well. So that means platform was reliable enough and fast enough for them to be relaxed. Beyond that, we're also getting the interesting experience and insights from our customers. You probably may have heard about some of them. It's a Mistral, Luma, JetBrains, Higgsfield. There are plenty of interesting names. As you know, when you train a model, when they actually do something related to the model, to the AI, you have a long cycle. You're starting from the data, you go through the experimentation, you do training, you do alignment, and then you actually could do inference. Today we have just 15 minutes for talk, so I could not really cover all challenges that you have, because each step have their own challenges. But I want to focus on the most, let's say, expensive one, the pre-training. Is actually when you take thousands of GPUs and you run them for a month, this is what costs like millions of dollars. So what kind of challenges? There are a lot of challenges, but I'm going to highlight 2 of them and give you like best practices and actually tell you how we transform those challenges into the features of our product. Let's start with the first and really obvious, how to select a cluster, how to get a cluster. So first of all, when you're looking for a big cluster, like a few thousand of GPUs, it's not that easy. You cannot just open the Google and find it. You actually need, I mean like Google search, and you actually need to go through multiple providers, find the best price, configuration, and you cannot really change those clusters continuously because each cluster is unique. It have its own firmware, it have its own network, storage, and you could not just change. You might actually face a problem just because of the firmware, because your version of PyTorch will have problems with this specific firmware. Another thing is provisioning and scaling. So it's not a question like if you need like thousands of GPUs, how fast people could actually bring them, cabling them, and launch them. And the last thing, those clusters are quite unstable. They fail continuously. But this is what we're going to check later. So what's a common practice, what we really recommend to do when you get a cluster? First of all, do a network testing. So use a CCL test to check that InfiniBand is working correctly with a full speed. You need to check the stability of cluster. So you actually need, before you launch your own training, you need to launch some trainings just to validate, trainings that you're sure that working correctly, that you can really use the cluster. You can full scale it, and you can use all GPUs on the maximum performance. And another interesting that, the inference and the training, it's absolutely different from the way, what kind of workload, the patterns you will see. And you actually need to test cluster with both. Otherwise, you might not find some problems that you will actually make a lot of, challenges to you in the future. So what we're doing for a cluster, before we taking anything to our clients, first of all, we're optimizing software and hardware. Then when the cluster is coming to the data center, we run a CCL test. We do ML Commons distributed training. So we validate the configuration, the performance. We do big inference of the biggest llama to check is it working correctly or not. We're doing that with array to utilize the entire cluster, and we also do the full-scale pre-training. So if the cluster survives that, if there is no problem or no mistakes, then we bring that cluster in face of the customers. Otherwise, we're not bringing it. We need to fix it. But we do it in the multiple stages. We do it on the fabric, where we produce clusters, and we do it in the data center again. The second challenge, I already mentioned that the clusters are failing continuously. And if you'll take a look on a public report from Meta about the training of the Llama model, you actually will find that there were 419 unexpected interruptions. And if you will just do a simple math, you will find that the cluster was failing every 3 hours. And this is unexpected. There were actually several more interruptions expected. So the cluster was stopped multiple times. But what's the problem with it? The problem is that if the cluster is failed, even if one GPU from 16K cluster is failed, you need to restart everything again, because there is no way how you can actually restart and replace just one GPU. And how to solve that thing? So to solve that, people use checkpointing. Checkpoints is like you do in a game. You just save where you are and you continue from this place. But what does it mean save checkpoint? So for the 300B model, checkpoint size is at 3.6 terabytes. And when you do the saving of the checkpoint, you cannot continue the training. You actually stop your cluster for that time. What's the problem with it? The problem is if you will just write checkpoint to the storage directly, it actually will take 90 minutes if you have fully utilized 5 gigabit network. So in other words, you stop your cluster for 90 minutes, and you're just doing nothing. You pay, I don't know, a few thousand, $100,000 for the cluster, and you do not do anything. That's not a way how you should do that. So there are several ways how you can solve this problem. First of all, do not write checkpoint from a single place. Instead of writing checkpoints from a single node, you can write checkpoints from multiple nodes. So in this case, every server in your cluster write a small piece of the checkpoint. It's called distributed checkpointing. And here, theoretically, if you have 128 nodes, you can do that in 45 seconds. In real time, in real life, because we're not living in an ideal world, we achieved 180 seconds to save the checkpoint of 3.56 terabytes. But is there a way to make it even better? Yes. Because usually what you're doing, you're writing checkpoints to the storage, and it takes 180 seconds. But there is a trick. Instead of doing that in this way, you can do two stages approach. So first of all, you write checkpoint into the memory of the server, RAM. Because you're doing calculation in GPU, your RAM is not doing anything. There is nothing in the RAM. So write checkpoint into the RAM through the super fast bus internal, and it could be done almost in 1 second. And then, when you finish that, you can continue the training and actually start to write to the disks. But here is the thing. So if with that kind of configuration, you do a checkpointing of 3.6 terabyte in 1 second, and you continue the training, and then you just stage it to the checkpoints. This is really interesting thing, that you actually could combine both approaches. So just to repeat, if you do a training, if you do a checkpointing, use distributed checkpointing, use asynchronous checkpointing, and better combine them. In this case, that's a perfect situation. But what we're doing as a cloud pod, because I said that we always use this knowledge to create the features. So one of the features that we created, we actually worked a lot on our storage. Because the storage also, we use our own storage software, we created it. And we learned the patterns of the workload, how actually PyTorch libraries and all those libraries working with the storage. So we optimized the storage, and we're able to provide 150 gigabytes per second. Not gigabits, gigabytes for each cluster. So actually, if you don't want to do things about the checkpoints, you can just write it, and we will be able to take your checkpoints as fast as possible. And the second thing, that if you want to learn how to build those things, just come and ask. We can actually share the code. We can actually share best practice for you, how to build such system. And we actually, some of our products support that just as a feature. So you just do checkpoints and it happens automatically. You don't need to do anything. Okay, so just to repeat, to build an AI-centric cloud, you need to have expertise in AI. Otherwise, you will not learn the challenges. And that's the reason why I said that every cloud provider who say that he's working in AI need to have LLM team to learn from them. What we have learned and what we have built based on this knowledge. So this is what we built so far. We have an infrastructure, as I said, we're managing data center, we own it. Then we build it, software stack. We have a Kubernetes, Slurm, virtual networking, so it's like a real cloud. And on top of it, we developed things like managed Postgre, managed MLflow, managed Spark, Ray, just to help you start using and train models immediately without working on infrastructure, without spending time on it. And on top of it, there is a console, there is an API, there is a Terraform, so you can do infrastructure as a service. And actually, we provide full on-demand self-service. So you don't need even to talk to us. You just open the console, create an account, add your credit card. If you want, you can use invoices, and you're good to go. Real cloud experience. And the last thing that we launched last week is a Nebius AI Studio, where you can get open source model and pay per token instead of GPU hours. So yeah, this is what we built so far. Because I said that there are a lot of challenges we learned about, but I mentioned just two of them. If you want to learn more, if you want to ask any questions, feel free to find us. We have a booth here. It's actually, I know that B6 is impossible to find because there are no numbers, but it's right in the entrance in the main venue, right behind the registration desk. So it's super easy to find us. You can also find us by nice t-shirts. It's really visible. Yeah, so this is what I want to tell you today about. This is my LinkedIn. If you want, let's stay connect. If you want to follow us. And we have some time for questions.
Thank you very much, Aleksandr. And as he said, we have some time for questions. So please do be brave. There are fewer of you now than earlier, so I'm going to need to maybe pick on people if you don't put your hand up. So please do. Come up with a question. Excellent. I can rely on you. I like this.
I'm curious about other related services that you have in your cloud provider. Honestly, I didn't know your product. Do you have something that is similar that you can easily also deploy API composed by several models? So something like the app service of Azure, to be clear.
Okay, so yeah, we know that sometimes people want just to launch models. So what we have done, we have a marketplace where we put a lot of software, and we also package the Triton server, we package the VLLM. So for example, you want to run your own model, you can just click a button, provide the name of the model, for example, from Hugging Face, and it will be launched for you. Yeah, you can do that.
Thank you very much. Any other questions? Come on, this is your one opportunity. Here we go. This gentleman over here.
My question is regarding the cloud, especially in the European space. Do you consider yourself as in the competitors for the biggest, let's say, American or the US cloud providers? And do you aim to be like the, let's say, the cloud provider within Europe for Europe?
So right now we are headquartered here directly in Amsterdam. Our data center in Finland. That's the biggest data center. We're going to expand it to 60K GPUs, and we have a second data center in Paris. And yeah, we're also planning to open the data center in the US, but first of all, we're in Europe, and we are already invested a lot in Europe. And yeah, the legal entity also in Europe, so.
Thank you very much. Any other questions? This gentleman is an expert in his very specific field as well around LLMs, and I'm sure there's a lot of people in this room who are thinking about utilizing LLMs. So yes, this gentleman over here.
Yeah, so thank you for your talk. It was really interesting. So I was wondering, you mentioned that there was many interruptions when Meta trained their model. You also trained your own model, so probably have some experience too. So can you maybe shed some light on how many interruptions you faced, or what were common issues when you were training the models?
Oh, that's a good question. Honestly, right now in my head, I do not have the data how much interruption we had. We definitely had them. Otherwise we will not learn about checkpoints. In general, one of the things why we building the data center, why we're building the servers, because we can see everything in them. So there was an interesting situation when we saw that the cluster performing not that as previously. So there was a degradation of the cluster performance. When we started to analyze it, we found that there is one GPU who's performing lower than everyone. And when you do a distributed training, you actually need to synchronize everything. And it means if even one GPU is not performing well, all cluster will performing not well. And we start to analyze what's going on, and we found that in one server, one fan was not spinning on a full speed. So that's why the GPU was a little bit overheated, and the GPU was throttling. So we just fixed that problem, and the cluster back online. So yeah, we faced the problem, but that's the reason why we decided to build everything by ourselves, because we control everything. And actually, when you use our cloud, it means that we see everything in infrastructure level, and we can do that, repair it automatically, so you will not be anyhow affected about it.
Thank you very much. Really fascinating talk. To be honest, I haven't heard any other talks at this event yet that have dived so deep into the infrastructure and architecture required for LLM. So really, really appreciate that. Thank you very much.